good morning students. Today we will continue inverse trigonometric function. In the previous class we have studied and we have defined inverse of sine function and inverse of cosine functions with their respective examples. In the same way we can define the remaining trigonometric functions of inverse function, inverse trigonometric functions. So in the previous video we know that sine inverse of x, its domain is minus 1 comma 1 and its range is minus pi by 2 to plus pi by 2. Similarly, cos inverse of x is defined as its domain is minus 1 comma 1 and its range is 0 to pi within a closed bracket. Similarly, tan inverse is defined as tan inverse of x. Inverse of tan inverse is defined as its domain is r and minus pi by 2 to plus pi by 2. Cot inverse of x is equal to, that is r, its domain is real number and its range is 0 to pi. Similarly, sec inverse x is defined as r minus of minus 1 comma 1, which is the domain of sec inverse x, and its range is, or principal value of sec inverse x is 0 to pi minus pi by 2, singleton pi by 2. Similarly, last one, cosec inverse of x, its domain is r minus of minus 1 comma 1 and its range is, or principal value is minus pi by 2 to plus pi by 2 minus singleton 0. Other than 0, all the values will be satisfied. That is a 1 and counter functions. So this is the after restricting the functions of a value, domain and range. So in the final exam, in 1 marks, they are going to ask you write the principal value of sec inverse x. Suppose consider sec inverse x. Write the principal of sec inverse x. What is the principal value? 0 to pi minus pi by 2. 1 mark question. Okay, write it down. So next, prove that sine inverse of minus x equal to minus sine inverse x. So we know that sine of minus theta is equal to minus sine theta. It is in the normal form. What about in the inverse? Sine inverse of minus x equal to minus sine inverse x. We have to prove this one. Okay. Solution. Consider let sine inverse of x minus x, sine inverse of minus x equal to y. Consider LHS sine inverse of minus x equal to y. So this implies minus x equal to. So that is minus x equal to sine y, because we know that by the definition of sine inverse function, sine x is equal to y if and only if x equal to sine inverse y. Similar. So minus x, multiply both sides by minus 1. Multiply both sides by minus 1. So we get x equal to minus of sine y. Minus y, sine of minus y can also be written as, by this one, sine of minus sine theta can also be written as sine of minus theta. Minus sine theta can also be written as sine of minus theta. So in place of theta, here we have y. So minus sine y can also be written as sine of minus y. Now again, this can also be written as sine inverse x equal to minus y. So this sine will come, LHS side it becomes inverse. So sine inverse x equal to minus y. Again multiply both sides by minus 1. We get minus of sine inverse x equal to y, because minus into minus plus. So similarly, what is y here? Here, what is y? Y equal to sine inverse of minus x. So therefore, sine inverse of minus x equal to minus sine inverse x. Similarly, we can prove one more example. So prove that tan inverse of minus x equal to minus tan inverse x, because in the trigonometric function we know that three functions are direct. Sine of minus theta equal to minus sine theta, tan of minus theta equal to minus tan theta, cosec of minus theta equal to minus cosec theta. So tan inverse of minus x equal to minus tan inverse x. Solution. Consider LHS. Consider LHS. Tan inverse of minus x equal to y. So this can also be written as minus x equal to tan y. Multiplying both sides by minus 1, we get x equal to minus tan y. So this implies, so this can also be written as tan x equal to minus tan y. That is x equal to tan of minus y, because we know that tan of minus theta equal to minus tan theta. So again take this tan to LHS side. We get tan inverse x is equal to minus y. Again multiplying both sides by minus 1, we get minus tan inverse x is equal to y. This implies we know that y equal to tan inverse of minus x. So substitute it here. We get tan inverse of minus x equal to tan inverse of minus tan inverse of x. This is the solution of this example. Hence proved. Okay, write it down. So consider next example. Prove that cosec inverse of minus x equal to minus cosec inverse x. Solution of this example. Consider LHS. Cosec inverse of minus x is equal to y. Or you can consider theta also. Okay. So this implies this can also be written as minus x equal to cosec y. Multiplying both sides by minus 1, we get x equal to minus cosec y. This can also be written as x equal to cosec of minus y, because we know that minus cosec theta equal to minus cosec of minus theta. So again take cosec to LHS side, we get cosec inverse x is equal to minus y. We remains only minus 1. Multiply again both sides by minus 1. So we get minus cosec inverse x is equal to y. What is y here? Y equal to minus of cosec inverse of minus x. Substitute that one. We get cosec inverse x is equal to minus cosec inverse x is equal to cosec inverse of minus